Hi everyone, we're busy with projectile motion and let's have a look at a second example of a problem. And this one was quite a challenge. So let's have a look. What did they ask them? Now this was in the November paper of 2015. Way back, I know, but remember, work out these old papers because they do repeat questions. Great, so let's see. Okay, the question is, or what they say you have that a certain ball gets dropped from a building and they give you the building as a 30-meter height building. They say a ball of A, let's say it's ball A, is projected upwards at a speed of 16 meters per second. And then we've got a ball B that is being dropped from the top of the building at an initial speed of 9 meters per second. Alright, now they say we have to use the ground as our 0 point. Now what we have this stage is that there is two things in the air at the same time. So we've got one ball being thrown upwards and another ball being thrown downwards. Alright, let's start with the easy question. Calculate the time that it takes the ball A to reach the ground again. So let's just look at A. So it's being projected into the air with the initial speed of 16. Calculated the time that it takes to reach the ground again. Now we know that the time up equals the time down. So I'm going to use that. So I do know that I've got here a final velocity then of 0 for it to just go up, reach its highest point, which would be 0. Alright, so let's decide on a direction. Because I started working with A, I'm going to choose direction upwards as my positive direction. So to work out my time, I'm going to use my easy formula, which is my delta y equals, let's just have a look. I don't have that. No, I don't need this one. This one is going to be, you see, that's how we go do it. You have to kind of like get used to try one formula and then change to another, which is fine. So I do have my final, I do have my initial, plus A delta t, I do have my acceleration. Remember, acceleration is downwards, so I'm going to put in a minus there. So for your final 0, for your initial 16 plus minus 9.82, which actually means minus. So we do work out the time. I worked it out already as 1.63 seconds. But remember, that is just upwards. So the total time for A would be 1.63 seconds times 2. And that worked out to be 3.265 seconds. And if I would just give it as a 2 decimal, it would be 3.27 seconds. Alright, so that was easy peasy. And we're going to now look at the second part of the question. So the second part of the question states 1 second after A was projected, a second ball B gets projected downwards at 9 meters per second. So what do I have to keep in time? Do I have to keep in mind? Time. Yeah, that time is on my mind. Yes. Why? Because it's not going to be the same time for both. So we normally have simultaneously, but in this question they say 1 second after the other. Now, let's say what do they ask. Now they're going to throw the question at us saying, calculate the height at which both ball A and ball B is at the same point, where they actually pass each other. So calculate the height from the ground upwards, where both ball A and ball B is passing each other. Alright. This is a difficult one. Now I first have to decide which of the formulas I'm going to be using. Now let's see, what do we have? We have a time for A, but it's unknown. We don't know what the time will be for A when B is exactly at the same point. So what we could say is, let's say the time for A is t seconds. It's an unknown, I don't know what it is. What else do I have for A? I do have the initial as 16. What else do I have for A? Yeah, well, G, of course. Upwards is positive, G is opposite, so that would mean downwards it would be minus 9.8. So, if I look at this, and they want to find delta y, which formula can I use? Do I have a final velocity? No. It's not to say that at 0 speed of A, that B would pass it. So actually, we don't have the final speed, which to me indicates don't use a formula where you don't have time, you don't have delta y, and you don't have final velocity. And also it's not asked. Therefore, I'm not going to use a formula where there is final velocity. So which one will I then use? Now let's go back to our movement just of A. Let's just say A is going to travel up to a certain point in a certain time when B is exactly passing it. Alright, so I'm going to use the formula that says delta y equals V initial delta t plus great. Now if I just look at A, and I've already stated that let's say the time needed for A to reach the point where B is passing it is t seconds. What would be delta y? Well, I don't know that. That's actually what I want to work out. So let's say we say that A, delta A, would equals x. I don't know. Let's say it's at point x where B is going to be passing it exactly on its way down. So therefore, I'm now going to have to put my values in. But I don't have a delta y, I just say it equals x. Is it positive or negative? Well, going upwards to that point, it's positive because I chose up as positive. The initial is upwards, so that's a positive 16t. Plus half of 9.8, but wait a minute, I chose up as positive, so 9.8 would be a minus. So it would be minus half of 9.8 is 4.9 t squared. And you see what I have here is two unknowns. Therefore, guys, just write your formula and stick it there. Now let's have a look at B. What is the motion of B? Now what happened to B is it's traveling downwards. Sure, okay, we've got to focus because we chose up as our positive value. Now if I look at B, this is ball B's movement. I have already that time is t for A moving up is t seconds. Now just for a moment, let's just think. Let's just use real values. If the ball goes up A and it takes 10 seconds, what is the time that B traveled to that point where it is exactly at the same point. It's being projected only 1 second later. So if T is 10 seconds, then B should be 9 seconds, correct? Alright, so that gives us an indication that then the time for B, so the time for projectile B would be T minus 1 seconds. Okay, that's the first thing we start with. T, time, scalars, I don't have to worry about direction. Now let's look at the distance or the displacement. X delta y, we stated, is x and a positive direction. But B is traveling in the opposite direction. So what would be the displacement of B? Now we've got that it's being projected from a building 30 meters high. So if they get to a point where they are exactly passing each other, can you guys see that it means the distance or the displacement of B would be then the 30 meters height minus x. That would be then the displacement delta y. So for B we can say delta y equals then that 30 meters minus the x, which is that is then the displacement or the position where ball B would be. So that is my delta y. So guys, you can see this is kind of a tricky one. Alright, so just think very clearly. So I'm going to keep it separate. This is A's movement. And let's have a look at B. So I'm going to use the same formula, saying delta y equals but upwards is positive. And I can't in the same problem now change it suddenly. I can't. So I have to stick with upwards as positive, which means that if I would put in 30 minus x, is my delta y downwards or upwards? No, it starts there and it would be at that point. So can you guys see that delta y is going to be a negative? So it would have to be minus 30 minus x equals another one. My initial velocity or speed is 9 meters per second, but downwards. But I chose up as positive. Oh my goodness, so it's got to be minus 9t plus, but wait a minute, A is always downwards. What did I choose as positive? Up. So it has to be minus 4.9 delta t square. Alright, so now let's start. Now we have to start using our best maths. And just stick with it, eh? So here we've got one formula. Let's just continue here. So we've got minus 30, minus times minus is plus x equals, oh, sorry. This is what I forgot to I put t in as t, but t is minus t minus 1. Okay. So it's t minus 1 minus 4.9 t minus 1 squared. Okay, that complicates things. Let's start. So it's going to be minus 9t minus plus 9. Here I've got a minus 4.9 times t times t is t squared minus 2t plus 1. If you want to just first write t minus 1, t minus 1, t minus 1, and then start working it out. But that is what my street term would be. Now let's continue. So we've got a minus 30. Let's take it to the other side. So we've got x equals minus 9t minus 30 plus 30 gives me plus 39. Then we've got minus 4.9t squared minus 4,9 times 2 plus 9,8t minus 4,9. Okay, so that gives me x equals minus 9t plus 9,8t, that is then 0,8t. 39 minus 4,9 gives me plus, let's have a look. I did work that one out. I am getting 34.1. And I have a minus 4.9t squared. Let's just make sure I used that one, I used that one, I used that one, I did use that one, I did use that one, and I've got this as my second formula. And as you can see, guys, now I have two formulas for x. Let's add them together. So it's going to be 16t minus 4.9t squared equals 0.8t plus 34.1 minus 4.9t squared. And the best thing in math is when you have two things which is exactly the same and I can stripe them out. So what do I have left? I have 16t, bring that over, minus 0,8t equals 34.1. And I do get t then eventually as 2,24 seconds. But that is not what was asked. The time wasn't asked. The height was asked. So what do? I'm going to just put my t 2.24 seconds in x, and I do get x meters. The height as, where did I work that one out? 11,178 meters. So I'm just going to substitute my t as 2,24 seconds. Then remember it's going to be squared, and I get to my final answer, 11.178. And this is by far, except of course the graphs, which is also going to be a bit tricky, projectile motion graphs. This is definitely one of the more difficult questions that you can expect. But guys, we rather want to do this on our own, working it out in our own time, than sitting in an exam and try figuring this one out. But believe in yourself, you can do this.